This conference will now be recorded.
Okay, in today's session, we're going to discuss about the Pandas operation. How to use a function, how to use a function. Okay, for example, if you're writing some user-defined functions, how to apply the user-defined function to each rows and each columns by using the apply function, we're going to see. And then applying a function on the possible series data frame, Pandas series data frame, how to apply a function to every row in a Pandas data frame. Then going to apply a function to each element of the series, and then going to perform some aggregations, like going to find the mean, minimum, maximum, count. Okay. Yeah, we're going to see all those things, and then we're going to cover the Pandas series as well as Pandas data frame. You already know Pandas is nothing but a one-dimensional array. Okay. If you have more than two columns in Pandas data frame, you can't convert to series. You can pick only one column and then you can convert it to Pandas series. Okay. Now, I'm going to take one data set. From the data set, I'm going to apply some transformation by writing the user defined function. Okay, the first requirement is I'm going to make operations, Pandas operations. It covers both transformation as well as aggregations. Okay, now I'm going to import my library, import Pandas as PD. First, I'm going to create a data frame by using the written CSV file, and then you can give the escape sequence. I'm going to take one data set. Let's go to ML folder. The ML folder we have TSLA dataset. Okay, it's nothing but a stocks prediction dataset. Okay, in that we have various columns. It contains all the stocks open, when the stock is open, when the stock is high, when the stock is low, when the stock is closed. Okay, and adjust to close and volume we're going to see. This is going to be a stocks prediction dataset. From this dataset we're going to use, and then we're going to apply some user defined functions as well as aggregations in this Pandas data frame. Now I'm going to save this tsla.csv file. Okay, just keep the format as it is. Now copy the path and paste it over here, and then give tsla.csv, and then try to read the first 5 records by providing head. Just provide by giving 6. You can able to see the first 6 records. Now what I'm going to do, in Pandas we have one function called apply function. We have one function called apply function, and see here apply. There will be apply is there and apply map also there. Okay. Now you might be wondering what is this apply function. In this apply function, you can pass any function on every single value of the Pandas series. Okay, you might have a question in this apply function, what we can pass. The apply function, you have to pass one more user defined functions, and then what will happen after applying the user defined function to this apply function, it will apply to every single value of the Pandas series. Pandas is nothing but a one-dimensional array. It might be a huge improvement for this Pandas library, as well as you can use to be able to segregate the data according to the conditions. If you have some conditions if you take any column, you have some conditions for that particular column, you can apply the user defined functions to every single value of the Pandas series. Okay, now what I'm going to do, I'm going to apply this function. I already said to you, for the apply function you have to pass one more function called user defined function. The user defined function will be applied to all a single value of the Pandas series. Now I'm going to show now. Before that, before applying this function, I have to write one function. How to write a function? Make it function underscore 01. This is a function name actually. In that function name, I'm going to pass an argument. Okay, I'm going to pass an argument called number argument. I'm going to write some conditions. Okay, like I'm going to write some conditions. If number lesser than 35, it's going to be I'll make something like number 35. Okay, number less than 15. It's going to be a low value. It's going to be what value it is? Low value. Okay, low value. And then I'm going to write multiple if conditions. If number greater than or equal to 15 and number less than or equal to 25, then I can say it is normal. Written in the single double quotes, you can use string normal, and then I'm going to write one else condition. If I get more than this value, I will return as high. I will return as high. This is a function I return. This will be going to the user defined function for me. As per my requirement, I return the UDF, user defined functions. Now what I going to do? I going to apply this user defined function to every single value of the Pandas series. Pandas series means it's going to a single dimension array. If you choose only one column, you can convert into Pandas series. Okay, now I'm going to apply this function just to make it as new equal to, okay, I already have data frame. I can apply this function only to this Pandas series. I want to choose only one column. Further, what a column I'm choosing is I'm going to choose a high column. I'm going to choose which column? High column. And then you can use apply function. You can use double tap. You'll get the apply function. In the apply function, what do you have to pass? You have to pass one user defined function. One user defined function. Okay, I have passed the user defined function. That's it. Now print the new value. It's going to give, it's going to apply the user defined function to every value of the Pandas series. Now we check the condition. It is 28.000, right? 28.00. I'll get, what's the value I'll get? I'll get normal. Next one is 30. 30 means I'll get high. Third value is going to be 20.92. It's more than 25, right? Now we're getting the high value. This is how you can apply the user function to every single value of the Pandas series. Okay, this is how you can able to see. Now, okay, now what I can do, I will go for another requirement, which is a very simple requirement. Okay, if you can write some user defined functions by using apply function, you can apply to every single value of the Pandas series. Now the second example is I want to add in the low, I want to add +3. I want to add +3 values for all the single value of the Pandas series. How to achieve this? It's very simple. This is the second requirement. Add 5 to the add 3 or 5. Add 3 to the stock values for low label. Now I can make some variable. low equal to, okay, df dot apply df dot apply, okay, it's the data frame, right? Okay, df dot apply. Now in the apply function, now I'm going to apply some transformation. That's going to be the anonymous function I'm going to apply. And so nothing but the lambda, and then I'm going to add some values. Okay, just I'm going to take assign some variable, and then I'm going to add some num plus 3. Though I have not used only a single column, okay, I choose all the columns in the Pandas data frame, df apply, and then I'm going to add the 3 in the all the columns. If you see open, high, low, close, adjacent, close, volume, I'm going to add. If you want to add some particular column, you can filter those columns here. df of low, you can filter those columns. You can apply the anonymous function by using lambda as an anonymous function. You are assigning some variable name. It will take every single value in this variable. That variable will you can add plus 3. Okay, this is how you can able to do the transformation. In apply, you can pass some user functions, or you can pass some anonymous functions. Now I'm going to print the value. Print low dot head. Able to see the, you can able to see the values, as well as I'm going to print df of low dot head. Now you can compare the things. Previously value was, sorry, I can make yeah, previously value was 70.5. After adding 3, it's got 20.54. Previous value was 20.2, 23.229. Now the value added 3, I got 26.2299. Okay, like this you can do some transformation by adding some UDF, or you can use some another function, and then after writing user information on another functions, you can use the apply function. The apply function will apply to even a single, every single value in the Pandas series. The Pandas series. Because you might have question why we can't apply df.apply. If we apply df.apply, the date column is going to be a, it's going to be not an object type, it's going to be a date type. This open is going to be a some float type. Okay, you can't apply the values for all data frame. That's why I'm filtering and applying the values, because this is going to be a integer, right? This is going to be integer type or float type. You can add plus 3, but didn't time you can't add plus 3 because its type is different. That's why I filtered the column, and then applying the, sorry, I filtered this column here and then applying the plus 3 over here. Okay, this is how you can do. You can write it in UDF, or you can use some anonymous functions. Now next requirement you're going to see how to apply function to every rows in a Pandas data frame. I'll write a requirement here. Every row I'm going to apply. I'm going to use apply function to every row. Every row in a Pandas data frame. Now I will take the data frame df of head, df of head. Now my requirement is, someone is saying to you to add all those values, open, high, low values, open value, high value, low value, and close values. You have to add all these things. For this, what you can do, I want to add all these values, because my requirement is I'm going to apply function to every row in a Pandas data frame. For every row I want to apply this sorry, I want to use apply function to every row in a Pandas data frame. I want to combine all these values, open, high, low, and close. I want to add all those values. For that, what I going to do, I going to write one function like I'm going to have the add function a comma b comma c comma d. Okay, in that I'm going to give the return type as a plus b plus c plus d. Okay, now what I'm going to do, I'm going to have the df in the data frame. I'm going to add a new column, add new col, new column equal to df dot apply. Okay, df dot apply. I'm going to use a anonymous function. Lambda is another function, and then I'm going to have a variable called row. You can have any variable name. Okay, I have some variable called row, and then I'm going to use this user defined function add. In the add, what I'm going to do, I'm going to pass the row name, row of what's the row name? What's the row name I can pass, like I want to row of date, row of date. Okay, and then comma, because for this add method how many arguments I have to pass? I want to pass 4 arguments, a b c d I have to pass. Now I pass only one argument, the three remaining 3 arguments I have to pass. Okay, now I'm going to add a row of, and then I'm going to pass high, and then row of, I'm going to pass low, and then row of, I'm going to pass close. This is how you can use apply function to every row in a Pandas data frame. Now I'm going to combine all these values by using this user function. I'm going to add all those values. Okay, now just hit enter. What happened? Apply add of row. Okay. Okay, I made a blunder mistake. Okay, just I have to pass this brackets, and then yeah, here I also have to change low. Here also you have to change. Are I making mistakes again? Yeah, like yeah, we can do one thing. I can add the axis. I can add the axis because I going to apply the function to every row in a Pandas data frame. Okay, because I'm choosing the columns here, right? Date, and then high, and then low and close, right? I want to make the axis as 1 because I'm passing the column names. Okay, just hit enter. Happen df dot apply lambda row of, sorry, I made a blunder mistake again. I choose the row of date, right? Instead of row of date is the something like it's a date column. Okay, you should not choose the date column because I want to add all those values. Just to choose open. Yeah, now you can use the df dot head. Now you can see the new column here, add of new column in the data frame. I'm trying to add all those values, open, high, low and close. Okay, open, high, low and close. If you add all those values, you will get 85.43. Can I add all those values? Are you getting 85.43? Are you getting 85.43 after adding all these 4 values? After adding all these 4 values, are you getting 85.43 4 zeros? 25, 23, 48, 48 and 55, 65, 65, 75, 70 plus 9, 85. Yeah, it's coming in exactly 85.4340. Okay, so because I'm adding all those values and then putting in one additional column. This is how you can write some user function. And then my requirement is I want to use the apply function to every row in this Pandas data frame. So I want to choose a column. Okay, from the column, if I know the column, then I can it will iterate the rows one by one. After that, because I'm applying all to the columns, that's why I'm making x equal to 1. Okay, and then I'm trying to add all those values. This is how you can do. Are you there? Yeah. Okay. Now the same requirement you can achieve in different way by using the numpy library. Okay, just import the numpy library, import numpy as np. Now I'm going to have the same requirement, just copy and paste as it is. Change the column name as _1. Now what I'm going to do, instead of using this kind of anonymous functions, instead of having this kind of anonymous function, just I'm going to do only one thing. I'm going to remove all the anonymous function. I'm going to have the numpy. From the numpy have here some function, some we have. Okay, just try to add all those values. Definitely it's going to throw the error because we have one column called date column. Date column cannot be added. Okay, just try to drop the column as of now. Okay, just you can do one thing, df of drop. You can do like this, df of drop. Okay, and provide the labels. Okay, labels you can provide, or you can provide the axis you can provide. Okay, now I'm going to provide the columns equal to, I'm going to mention the column as date column, and then axis equal to 1. Yeah, I have dropped the column, date column. I have open, high, low, close. These are values I have. Now I'm going to apply the, now using numpy I have some function. Just hit enter. What happened? Yeah, can only concatenate string, not float values. Okay, it's saying like that you can able to concatenate only strings, not float values, because we have so much of float values here. We have so much of float values you can see here. That's why it's not able to. Mm, can only concatenate string, not float to str. Okay, what we can do here? What we can do here? I'll do one thing. For this particular thing, I will create a new data frame. Just create a new data frame. New data frame. Just give the label name as something like price. It's going to label, and then keep some values 90 comma 78 comma 89, and then you have some other values like um, load, some label name like 23 kg, 56 kg, and 67 kg, and then gauge. Okay, gauge I can give some labels, gauge, and then give some array values like 8 comma 9 comma 22. Okay, now we're going to create data frame. Df underscore 1 equal to, sorry, df underscore 1 equal to pd dot data pd dot data frame. Shortcut is not working for me. pd dot data frame, in that you can pass your data. Sorry, instead of writing cell, I'm writing comment part. Now data frame is created. Now directly I can going to have a new column, like add underscore 1 equal to df underscore 1 dot apply. In that I going to use a numpy library, np dot some function. Some function I going to do like x is equal to 1. Okay, now if you use a you can assign to def underscore 1 itself. Now hit like df underscore 1. Now you can able to see the values. Okay, I added all the values 90, 23 and 8. I got 121. 70, 56, 9. I got 143. 8 and 67, 22. I got 178. Okay, now I am trying to add all those values. This apply function is going to apply to every row in a Pandas data frame, and then I'm going to add all those values. Okay, this is how you can do, or this is going to second way. You can have assign one variable called row, and then you can choose a corresponding column, and then you put mention x is equal to 1. These are the two ways you can use apply function to every row in a Pandas data frame. Okay, now third requirement is how to apply a function to a Pandas series. How to use apply function to a Pandas series. How to use apply function to Pandas series. See, if you use apply function to Pandas series, it's going to invoke the pass function on each element of the given series object. What will happen? If you use apply function, what will happen? It's going to apply on each element of the given series object. Okay, now for this I'm going to create one additional data frame, because I'm going to create a series, right? I want to create a one dimensional array. For that, what I'm going to do, I want to create one series ser equal to pd dot series. Already Pandas we have pd dot series. Now I'm going to create a one dimensional array. The one dimensional array going to give like Chennai, Calcutta, Mumbai, Jaipur, and then Hyderabad. Okay, now create the Panda series. Now for Panda series, I want to create a index. If you're not able to create an index, that will assign a integer value, or if you have huge values of Panda series, it's going to assign a hashable type values. Now for my Panda series, I'm going to assign some index. Okay, I'm going to have some variable index underscore equal to, I'm going to have okay, I will take as a list itself. Okay, I have the list, and then I'm going to have like city 1, city 2, city 3, city 4. City 1, city2, city3, city4, city5. Like this, I'm going to create an index. City1, city2, city3, city4, city5. Okay, 1, 2, 3, 4, 5. Totally, I have the 5 cities. So 5 cities I created index. Now for my Panda series, I want to assign the index. How to assign the index? It's very simple. Scr dot index equal to just assign a variable name. That's it. Now, if you print those series cr, you can able to see for Chennai, the index will be city 1. For Calcutta, the index will be city 2. For Mumbai, the index will be city 3. For Jaipur, index will be city 4. And Hyderabad index will be city 5. Like this, you can assign the index value to your Panda series. If you're not able to create any index, it will take the integer values. If it's a huge value, series value, it will take the hashable type values. Now I'm going to filter the things. Just to have some variable called results equal to. I'm going to apply the Panda series SCR, and then I'm going to apply the function. Going to use apply function. In the apply function, I'm going to use anonymous function called lambda. Lambda function is not having any name. I'm going to take some variable called y. Okay, yeah, I'm going to assign variable y. Now I'm going to apply the list comprehension. You already aware of the list comprehension. First, you have to write some if conditions. If already have some y value, right? If y value is equal to Jaipur is equal to Jaipur, if file is equal to Jaipur, we're going to print it's a pink city. We're going to assign it's a pink city. Else going to assign it as same y itself. Going to assign same y itself. Okay. If I add some condition, it's a list combination actually. If the y value means first Chennai will come, right? Chennai equal Jaipur will check. If word satisfied, it's going to give only Chennai. Second value is Calcutta is going to come, and then going to compare with Jaipur, and then third value is going to come in Mumbai, and then finally come to Jaipur. Once Jaipur come, you print print pink city. If not, it's going to print the default value present in the Panda series. Okay, just hit enter. Now you can print your results that will going to display your that is going to display your values. This apply function is going to apply on each individual element on the Panda series. Okay, just I want to print it. That's it. Print results. Now can I see city 4? I'm not getting Jaipur. I'm getting pink city. This is how you can able to achieve the apply function in the Panda series. You can apply in DataFrame as well. You can apply in the Panda series as well. Okay. Okay. Yeah. Now, what I can do, I can replicate the same example itself for the date ranges. Now I'm going to do the same thing. I'm going to replicate for the date ranges. Okay. Let me just to create Panda series. I have some variable name pd dot series. In the series, I have some values. I'm going to have some values like 45, 67, 89, 23, 56, 90, and then 45, 67, 90, and then have some none values. Okay, now I want to assign some index for my Panda series. This time, what I'm going to take, I'm going to have the date as index column. For that, what I am going to have like index underscore 1 equal to pd dot date range. We already seen the date ranges. I want to provide the start date. The start date I'm going to provide like 2010 uh, 10/09, 10th month, 9th date, and then I'm going to give time as well. 8 hours, like 45 minutes I can give, and then I'm going to provide a periods. Periods equal to 11, something you can give, and then frequency. Frequency, what I can do, I can give the year frequency. We can provide Y. Now, what happened? Just hit enter, and then I want to assign this index to my series, Panda series. Scr underscore, okay, scr underscore 2 dot index equal to index underscore 1. This is how you have to assign the index, and then you can print the. Now you can able to see for 11, for 11. Hold a minute. 1 2 3 4 5 6 7 8 9 10. Yeah, I have 10 11 values, right? Including none, I have 11 values. Okay, including none, I have 11 values. For this 11 values, I get the date range. This is the index column. Now you can see the index column is going to the timestamp column, right? And then for 11, this is going to index. For 45, this is going to index. Okay, okay, let it be. But here the frequency given as hour, frequency given as year. You can see year only increased 11, 12, 13, 14, 15, 16 because we given a frequency. If you want to increase for months, you can give M. If you increase for days, you can give D. Okay, like that you can change the frequency. Now I have created the Panda series. In the Panda series, I'm going to apply the anonymous function. You already know like how to apply the anonymous function. I'm going to have some variable called result equal to Panda series 2. In that I'm going to apply the anonymous function. Okay, now I'm going to apply, I'm going to use a lambda anonymous function, and I'm going to have some variable called x. I'm going to apply the list comprehension. First, we have to check the condition. If the x value is greater than 25, I'm going to return true. I'm going to return true. Else, I'm going to return false. Okay. Now hit enter, and then you can print the result. Now you can see whichever value is greater than 25 got true. Whichever values got less than 25 got sorry, whichever value is greater than 25 I got true, whichever value is less than 25 got false. Okay, now you from this I can conclude that you can use apply function to every Panda series, to individual element of the every Panda series. Okay, this is how you can use the anonymous functions. Now I'm going to show how to perform some aggregations on the data. If you have one columns or more than one columns, how to apply the aggregations. You already know about aggregations in the SQL itself, right? Count, min, max, average, okay, and then absolute values. Okay, these are the aggregations you can perform. Now, aggregations you can apply. Yeah, you can use min, max, count, average. These are things you can find. Yeah, now directly I'm going to apply my aggregations on the data frame itself. Now I'm going to choose some other data frame. df2 equal to read df2 equal to pd dot read csv. I'm going to the escape sequence, and then I'm going to the YAML folder. In the YAML folder, I have some dataset called nba.csv dataset. Just copy and then use nba.csv and then df2.head. Now you can able to see the 5 records. In this dataset, I am going to apply the aggregations. Now, uh, you already know aggregation works with the numeric type columns. Aggregation works only in the numeric type columns. String type columns aggregations will not be performed. So what I going to do, I going to use df2 DataFrame 2. We have called aggregate function. In the aggregate function you can perform some aggregations. Okay, I going to pass as a list. Okay, instead of dictionary I can pass as a list. In the list what I going to do, I first aggregation going to perform some aggregation. Second aggregation is going to perform minimum. Third aggregation is going to perform maximum. Okay, just hit the enter. Now you can able to see the values, aggregation values. See, I already said to you, here you have so many columns, right? Here you have a name column, team column. These are all called string columns. For string columns, you can't perform any aggregations. Only for number columns you can perform the aggregation. That's why it is applying only to this age column, and whichever column is integer type. For that column only you can able to find the aggregations. That's why we're finding the sum, minimum, and maximum. For these are the four integer columns we have, and then for these four columns we are finding the array. We're finding the aggregations. I hope you understood. It's very simple. Just you have to pass aggregate function, and then you can pass arguments sum, min, max. That's it. As a list you have to pass. Okay, next is going to be the example. What are the example I can show? I can go for second example for to perform the aggregations. It's very simple. I can go, it's the second approach actually. I can mention this second approach to perform aggregations. Just we'll go for the second approach to make our hands dirty, to get our hands dirty. Okay, now df2 dot, you can use aggregate. Before that, what I can do, first filter those first filter those records, the first 5 records. Now I'm going to apply the aggregate, the second approach. I'm going to pass as a dictionary. I'm going to pass dictionary means you already know keys and value pairs. Key I'm going to pass column name. Which column name is integer column? Number column is going to integer column, right? The key column, and then I'm going to pass a list. In the number column I'm going to perform some aggregation, and then I'm going to perform the minimum aggregations, and then I'm going to perform the max aggregation, and then okay, and then what I can do, comma, again column I have age column, I have the key, and then what are the aggregations I'm going to perform? Max and min. Only max and min I'm going to perform. Max and min. Max and min. And then third column I have weight column, right? Weight, sorry. Weight, going to key. Then can have someone list. I'm going to perform what I can perform, min and sum. Min and sum I can perform, comma. Last is going to be what column? Salary column. Key. Then you can have one list. In that you can pass only sum. I'm getting some exceptions. Let's check. Yeah, some. Hold a minute. Yeah, though it's twice, right? On some 1 minute. 1 minute. Some minimum. Number I have choose. Age I have choose. Weight I have choose. Salary I have choose. everything is correct. Age, number, salary, weight does not exist. Okay, because I am choosing the df. I want to change, make it as df2. That's the thing. And then you can provide max as well. Yeah, now you can see for number column, sum will be 80.8079.0. Okay, for age, age sum will age. I don't have a sum. That's why I'm giving not a value. For weight column, I getting the weight. For weight and sum, you have to see. And then our salary are performing sum. This is a value. I'm getting a very huge value. That's why I'm getting exponential values. For minimum, you want to find a minimum. Okay, 0.0. And then max, I got 99.0. Okay, this is how you can perform the aggregations. This is going to second approach. Okay, and then now I'm going to show how to find the mean value. You already know what is mean value, right? First you have to take the average. First you want to add all those values and divide by total number of value. That's going to give the mean. Okay, if you are performing any data analysis, if you are doing some data analysis on the statistical information, you should know. First you have to find the mean, median, mode. These are static information you want to provide. For in DataFrame, you can apply the find static informations. You can get the static informations. We have one function called mean function. The mean function is going to return the mean of the values of the requested axis. If you need for row, you can provide axis equal to 0. If you need for column wise, you can provide axis equal to 1. Okay, it's going to provide the mean of the values for the requested axis. Okay, now I'm going to find the mean. I already said to you, mean value can be able to find only for the numeric values, not for any strings or date objects. Not for any strings or date objects. Okay. Now I'm going to perform the mean. Just df2. We have mean, median, mean absolute. Okay, MIT stands for mean absolute value. Okay, I can do the masking, everything I can do. Now I'm going to find the mean. In that mean, I'm going to perform for the row wise. I already said to you, it will apply only for the numeric columns, not for any string columns. For number value, the mean is going to 1.7678. For age column, the mean is going to be 2.69. For weight column is going to be 2.2152. So salary column mean is going to be 4.84. Okay, I'm getting some exponential values. Okay, these are the values, mean values. These are the mean values. You can do one more thing. df2, you can find the mean value. Sorry, you can find the mean value. You can find the mean value by providing the axis. Okay, by providing the axis, you can provide. This is a column wise. You can get the mean values, and then if you want to skip those not a values, you can give true. Okay, same thing you can apply here also. If you want to skip those not a values, you can give true. Now you can see some variation in this mean because I'm skipping this NA values. This is how you can able to perform the aggregations. Now I'm going to say how to apply mean in the Pandas series. Till now you've seen on the Pandas data frame. Now I'm going to say how to apply the mean to the Pandas series. Mean function going to return the mean of the underlying data, we can say for the given series object. For the given series object. Okay, now okay, same example, but this time I'm going to try for Panda series. Going to apply mean for the Panda series. Okay, now I'm going to create a series variable equal to pd dot and then I'm going to have some list. I'm going to pass some 10 comma 25 comma 60 55 comma 67 89, and then going to have an index column variable. First we have to assign the variable, and then I'm going to have some cool drinks brand, Mazda, Coca-Cola. Okay, and then I'm going to have Sprite, and then I'm going to have like Sprite, and then 7 Up, 1 2 3 4, right? And then I'm going to have some Goli soda. Okay, this is going to be the index column. These are the price of this brands. Okay, like Mazda is going to 10 rupees, Coca is 25 rupees. Like the price values for the each cool drinks. Now I'm going to have some index sr3 dot index equal to index underscore. Now if you print SCR3, now it's going to give the Mazda is going 10 and Coca is 25, Sprite is 55, 7 is 67, Gold is going to 89, and then these are going to the index columns. Now I want to apply the mean. Okay, it's very simple. Just to have some variable called results equal to take Panda series 3. You can apply the function mean function. You can apply, and then you can print the results. Now the mean value for the Panda series is 49.2. Add all those values and divide by total number of values. You get 49.2. This is how you can apply the mean function in the for the Panda series. For the Panda series, as well as you can add some none values as well. Okay, I can add the none values, and then I can give some name soda. Just enter. Yeah, now soda are getting the values, not a value, and then you can find the mean. Okay, now if you try to apply the mean function, it's going to skip the NA values and going to find only for the numeric, only going to find the mean and displaying as 49.2. 49.2. The last requirement we're going to see, it's called MAD, mean absolute deviation. Okay, this one kind of statistical information you can gather for doing machine learning models. It's called MAD. MAD stands for mean absolute deviation. Mean absolute deviation. Okay, the expansion is mean absolute deviation. The formula I'm going to mention here is MAD equal to it should be a sigma, and then I can say like yeah, I don't know the brackets right now. Yeah, sigma, and then first I want to get the individual value xi individual value, and then I want to find the mean of all the xi values, mean of all xi values divided by total number of values. This is the formula. Summation of, not sigma, summation. Okay, summation of, not sigma. Made a mistake. Summation of xi means individual value in the Panda series, and then total mean of the Panda series. You have to subtract the values and divide by total number of values. How many values you have? This is a formula. This is how you can calculate the mean absolute deviation. how the values deviated from the mean. If you're gonna ask what is the mean of the deviation, you have to say how far the values got deviated from the mean. Mean means it's one of the some kind of average values. From the average, how much values deviated for this? You have to do the measurement. MAD equal to summation of xi minus mean of all xi values. Xi means input values. Okay, divided by total number of values. Now I'm going to have for this to find this mean of the deviation. I'm going to have one example. Just going to have one list. In the list, I'm going to have all those values like 23, 0, 56, 78, 99, 123, and then 456, 90, 55, and then 31, 69. Okay, these are the values I have in the list. Now I'm going to create this list into Pandas series. How to convert list into Pandas series? As a variable, it's very simple. pd dot series. In the series, you have to pass a list, lst. Now you can convert the list into Pandas series. Now I'm going to have one variable and then a series of 4. Now I'm going to apply the mean absolute deviation. We have one function called a MAD function. MAD is nothing but the mean absolute deviation. It's one of the function actually. Now I'm going to apply this mean absolute deviation to this Pandas series 4. Okay. Now it's calculated. Now you can print the results. Now you can print the result. The value is going to be 69.71. Okay, this MAD function works on this logic only. Summation of xi of minus mean value minus the mean of x value divided by total number of values. I got this value. If y are calculating this mean absolute deviation in the sense you are calculating deviation of values, how far it is deviated from mean. This is how you want to calculate the mean absolute deviation. Okay, this is also one kind of aggregation to get the statistical information about your data frame, or it can be a Pandas series. Okay, now I'm going to stop session right now. We are going to discuss few of the aggregation method tomorrow.